this video, we want to look at the reflection of light. I gotta get my pen going. Let's find a nice color here. I guess that'll work. Reflection. Reflection of light. Well, when we talk about reflection of light, we're usually talking about reflection off a mirror or some type of smooth, shiny surface. And we're going to take the three basic types of mirrors and just go over them real quick. You probably had this before, so this shouldn't be too much new to you here. First of all, let's take a flat mirror. Oh, well, let's see if I can draw a little bit better flat mirror there. See if I can get rid of this. And let's try this again. See how my flat mirror goes. And we need a mirror. I guess that's not too bad. And let's get a different color for the light. Alright. Usually when you have a flat mirror, we're going to look at the angle of reflection and the angle of incidence and the angle of reflection. So we need a dotted line in here. And this is called the normal. This is the normal. And normal is always perpendicular to the surface. So when you get up in the morning, brush your teeth, whatever, that would be a flat mirror. And let's look at some rays here. You probably know about rays from math class. And let's draw some rays here of light. Say we've got this ray, it hits, and like a billiard table, it will also bounce out. And intuitively we know, if you've played basketball or anything, usually the angle it hits the floor with is the angle it's going to bounce off at. Even, in tennis and that type of stuff. So the incoming ray, we can measure the angle from the ray to the normal, and that's the incident ray, and then we can measure this angle, and that's the reflected. And what this is telling us, the angle of incidence equals the angle of reflection. And this is the reflected ray. This is the reflected ray. And this is the incident ray, or the incoming incident ray. Or the incoming ray, if you want to think of it like that. And this just very simply put, this ray, the angle it strikes a smooth, flat mirror, is going to be the same angle it's going to bounce out at. And you have a normal in here, which is always perpendicular to the surface. All right, we're going to look at a couple other mirrors here. So we'll switch this. All right, let's look at a concave mirror. And we're not going to get into this in a lot of detail. You'll pick that up in physics class. But a concave mirror bends in, or you're walking into a cave that the direction of the light is coming from. So let's see if we can get some nice color light over here. And let's say our light is out here. And so the ray is going to strike the mirror right here. But according to our, the law of angle of incidence equals the angle of reflection, it's going to bounce out this way. Likewise, if we've got another ray coming in, strikes, and this one's going to bounce out that way. And so they do cross. And what you end up getting, you're getting quite often with a concave mirror, you get a magnified image And if you're beyond what's called the focal point, or within the focal point, it's going to be right side up. If you're beyond the focal point, it's going to be upside down. Girls quite often use this. Women, I know my wife uses a concave mirror, for makeup application. If you got a compact for makeup in your purse, what you'll find that it is slightly concaved. And so really the beauty of a concave mirror, if you're within this focal point, somewhere in here you get a magnified image. And I think we've all have seen that at one time or another. And we'll move on to a convex mirror. A convex mirror, and let's see here, convex. Convex mirror is like the back of the spoon, if you will. And again, we have our light out here. And let's see if we can get a nice color here for the rays. And our convex. So when this strikes, seeing it's bowed outward, what ends up happening is the light does not come to a point but spreads out. And in a convex mirror, the advantage of a convex mirror, you get a greater field of view. Greater field of vision or field of view. You see these mirrors quite often in grocery stores, along the aisle. You can see over a couple, but maybe the biggest use is objects in mirror are closer than they appear. See these on cars, especially on the passenger side. Objects in mirror are closer than they appear. And again, the big advantage when you start using a convex mirror is you get a greater field of vision. So that's all we're going to cover as far as mirrors. In the next one, we're going to look at refraction and on a couple different types of lenses there.